Hello all of my viewers. Today's I study very much important and also interesting topics about the homomorphism of a group. Let's watch this video. If phi be a homomorphism of a group, actually it is of a group G into G dash, and then we can say there is a type of homomorphism G into G dash, then we can say that phi of E, that is phi of identity element, is equal to E dash, where E and E dash are the identity elements. Actually they are identity elements of G and G dash. That means E is the identity element of G and E dash is the identity element of G dash respectively. And next condition is phi of x inverse, that will be phi x whole inverse. This element exists for all x in G. All x belongs to G. Now we have to prove this interesting result, and this is very much useful also in many cases of morphism properties in abstract algebra. Let's watch this video. Now we are going to prove these two above results. At first we have phi x E dash, and that E dash is the identity element of G dash. That means phi x of E dash is equal to phi of x, simply we can easily say, because if we operate with the identity element, that remains same. And phi x also can be written as xe, as x into E is equal to x. So phi x can be written as phi of xe. Now using the property of homomorphism, phi of xe means phi x phi e. It is a property of homomorphism. Now we are going to the next stage by cancellation rule, because phi x E dash is equal to phi x phi e. So by left cancellation, easily that E dash is equal to phi, that is phi is equal to E dash. This proves the first part of the theorem. It is the first part which are going, that phi is equal to E dash. So first part already proved. Now we are going to the second part. Now to prove the second part, we have E dash is equal to phi of E. We are just writing this result, that is E dash is equal to phi of E, and E that can also written as x inverse. So phi of E is equal to phi of x inverse, which imply E dash is equal to, using the property of homomorphism, phi of x inverse is equal to phi x inverse, and which imply that's the property of identity element, inverse element of a group. Simply phi x inverse is equal to identity. That means one is the inverse of others. That's why phi x inverse is the inverse of phi x whole inverse. One is the inverse of others using this property. So phi x inverse is equal to phi x whole inverse, and which is true for all x in G. That leads to the second part of this theorem, and hence the proof. So this is very interesting result. We end our discussion today. If you like this video, like it, share it, and always subscribe the channel and press the bell icon to get all the notification and latest update all of my videos. Keep watching all of this video. Thank you.